All right. I have to watch it. And critique myself.
Is it on? She just said how bad
So, yeah, it's on. So hopefully it doesn't turn off. Alright. Alright, so let's go ahead and get started. Like I said,
They're reuniting.
that's a good song.
Can you show me a new song? It's pretty good. Jump Street. That's not my whole life.
Alright, I just put some blue triangles on your desk. Be careful, there's one that's super tiny, so please don't lose it. Yes, number 5. What I want you to do, other than Dallas, who does not have a partner, with your partner, I want you to group these triangles together. Any way you think the way they need to be grouped. And then we're going to talk about why you group them that way. Think about the shape of them, think about the size of them. I want you to group them. Yeah. Think about what they have in common.
Because they're right at
That's right.
Oh yeah, don't make a shake out of me, honestly. Like separate groups, what they have in common. So why did you do that?
Shut up. This was going
What if she's like watching that back and it's like, does your butt hurt? No, mine really does. Data, this was really
Okay, what y'all do? Angles. What do you mean?
right.
Cute right obtuse.
If you hear somebody say my butt hurts in your video, it's real.
I'm sure my professional life here.
I forgot that he's there.
Above and beyond, y'all. Above and beyond. What y'all do? Well, you heard him.
Hey, how'd you group them?
I think this one
right.
it was easy.
I don't know what I can't take that.
That's one. Big, medium, small. Alright, I think I talked to everybody. Look, I had protractors, only one group asked one, but that's fine. But you can really look at them from just seeing them. He wanted to be super exact, which he wants to be super exact. Alright, so a lot of y'all, what you did is that you paired them based on their angles. Right? A lot of y'all did that. When you base them about their angles, what do you notice about their size?
They're the same thing, just bigger and smaller.
They're the same thing, but bigger and smaller. If you look at your little groups, especially the right ones, number 1, number 7, number 9, that a lot of y'all put together, set them next to each other. Number 7 is like a shrunk version of number 9. And then number 1 is like a medium version of both of them, right? So that's what we're talking about today. Hatcher said it during when he was going, and I tried to get him to say it louder, but he didn't. But he was talking about proportions. These two are proportional to each other. It's just a shrunk version, but they shrunk it all around. They didn't just shrink one size, they shrunk every side.
But 8 and 6 don't look alike at all.
8 and 6.
Or 2. 2 doesn't have really match.
So if you, also, I could have had error whenever I was cutting them out. But you can kind of see that they're kind of similar. These aren't as obvious as the right ones are. But look at number 4 and number 6.
Yes, they look alike. Yes.
I wanted to see what y'all would do. Number 5 and number 3. They're just different sizes of the same triangle. Alright, so now put them all together and put the paper clip back on. I'm going to pass out your notes. And I want you to get out your one Chromebook for the pair.
Isn't that a great song?
If you need one, I have one. Just put the paper clip on it, send one person and bring it to the table. Oh, sorry. Once you get your Chromebook out, please go to Google Classroom. Who else lost their paper clips? Put on there. Alright, y'all get out your Chromebooks and go to Google Classroom. No, I gotta show you something.
I just couldn't hear it after my head.
Alright, head on over to Google Classroom. Alright, y'all, look. I posted something on Google Classroom for you to look at. You can share a laptop. If you have your own, then you can use that too. But go on to Google Classroom and click on that link. When you click on the link, this is what you're going to see. Wait, look up here. Watch me. What I want you to pay attention to, look at these little things. This little slider, y'all look. This little slider makes the purple one bigger. Oh, my computer's not working again. Bigger or smaller. Okay? The only way I can move them is I can move the orange one. But watch as I move the orange one, what happens to the purple one.
It goes the same way. It makes it bigger.
So this is how you make it bigger and smaller. And then this is how you can move the triangles around. But what I want you to look at is I want you to look at the angles. I want you to write down anywhere on this sheet of notes. Here's a big old blank spot anywhere. Just write down what you notice about them. As you move them around, what do you notice about these triangles? These are like the triangles that you just saw, but now we can move them around. So just play around with it. Write down what you noticed about it. That's what she has. The orange one is kind of new. What's still the same, Maria?
Their angles. Even if they're
Y'all know. But I still say the same, but still grow and shrink. Lower side.
the angles stay the same. Even if it's
And the equation, what's that equation? What were those called? Yeah, last class. Ratios, thank you. The stuff on the bottom are ratios. Thank you, Matthew. I want you to see if you guys can notice what those are doing too. Anywhere. I just want you to write down the stuff. What's proportionate?
Yeah. At all times.
We're doing this, girls.
Can you please actually make a triangle?
You know what those ratios are? What are they comparing? You don't notice anything else? How about I talk? Let's go back. What y'all notice, girls? I just want you to I just want you to write down, jot down. What did y'all
write the same thing. And I look down.
Y'all looking good. Y'all looking good.
Where are we supposed to write it on the paper?
Anywhere.
What are we supposed to write? Like, what's the
Alright, y'all.
Matthew, is today the day Mr. Merchant here?
So let's look up here. Shut the Chromebooks. That's what I wanted y'all to see. Y'all are doing awesome. Discovering and investigating. Alright, put up the Chromebooks and look up here. I think the consensus, or everything everybody agreed on, was what? What always stayed the same? No matter what?
angles.
The angles. No matter how I move this guy, which my computer doesn't really like me, but no matter how much I move this orange, the angles are always the same. I think Matthew was the first one to notice what these are. What are the things on the bottom called? Ratios. Notice, let me see, I gotta pull up my little pointer. Alright, now look right here. This says XY over, look, I just want you to watch. XY over AB. Look at these angles that connect them. 26 to 102. 26 to 102. When you connect those angles that equal each other, these sides are called corresponding sides. So watch, if I flip this guy, which none of y'all did, which is fine. Let's see if I can flip it. If I flip it, if this will work for me. I know. Okay, if I flip them, still, this side is no longer, this is important, this side on top is no longer corresponding to this side. Because look at the angles that I'm connecting. 26 to 51. And then this angle I'm connecting 26 to 102. So those are no longer corresponding, I have to match the same angles. So if I go to 26 and 102, and 26 to 102, it's flipped, but those are still the corresponding sides. The corresponding angles, like y'all saw, are the ones that just equal each other. The ones that are exactly the same. Alright, but look. What did y'all notice about this little slide or doohickey thing?
Didn't matter how big they got, there.
What, so again?
It didn't matter how big they got, but the angles are still the same.
So as you grew this, the angles stayed the same. What did you notice about this number and these numbers? They're the same. This is called the scale factor. If my scale factor is at 1, if I can scroll all the way down to 1, don't let me. That means I took every side of this triangle and just multiplied it by 1. So this is exactly the same as this for its sides. But as I grow this bigger, this is saying I'm going to take this side length, multiply it by this number, and I get this side length. What did we say when all the ratios equal each other? What does that mean? They're proportional. So no matter what I do to this triangle, these triangles stay proportional. So the angles are always the same, and the sides are always proportional. And that's what I wanted you to see in this little discovery activity. Because I think it's easier to see it and then put a definition on it. So now, let's go to your notes and let's talk about this, how we can use it in equation, and how we can use it in our lessons. Alright. Alright, so what we did today, those are called similar triangles. And you could have seen it in the top right corner. I'm glad nobody yelled that out loud. These are called similar. They're not congruent, they're not the same, but they're similar. Like I'm similar to my sister, or James is similar to his brother that's in the 12th grade. They don't look exactly alike, right? But they're similar. They kind of share some characteristics, and that's what this is.
They're both weird, they both play tennis.
No.
I shared nothing with my
They're both move out of the
Alright,
story.
yeah. Alright, look.
And one of them gets very
So write this down. What does it mean to be similar? That's what we just talked about. Similar polygons, alright y'all, let's go. Similar polygons are polygons with the same shape. But different sizes. So using this definition, can a triangle be similar to a rectangle?
No.
No. They need to be the same size, and they need to have this angle relationship. It wouldn't make sense for a rectangle to be similar to a triangle, because this guy has 3 angles, and a rectangle has 4. Those angles could never equal each other. Alright, so what we saw in GeoGebra for triangles can be related back to just every polygon you can think of, what we went over last class, or last unit. So for similar polygons, corresponding sides are congruent, which is that little symbol. You go like that. They're congruent, but what about the sides? What did we say they were?
Bigger or smaller?
Bigger or smaller, what's that? Proportional. So corresponding angles are congruent, they're always the same, but the corresponding sides are proportional. So the triangles that y'all saw in the GeoGebra didn't have the values. So now I need to let you see, when you see the values, how can we find out if a pair of triangles are similar?
If their sides are the same.
If their angles
If their
are equal.
angles are
Their angles are equal and their sides are proportional. Once I check both of those things, I'm done. Those are similar polygons. So look, I can tell that 40 and 40, 86 and 86 54 and 54. So these are the corresponding angles, and as you can see, they're all congruent. So that's my first check. Check. My second check is to see the corresponding sides are proportional. So when I do the corresponding sides are proportional, I have to actually do this twice. I have to see if the two proportions I make are equal. Alright? So this is what I was talking about matching the angles. When I go from this angle to this angle, on the other side, I have to go from the same angle to the other angle. Okay, so watch this. So if I go from 40 to 86, I have to also go 40 to 86. So now I compare these two. When we compare two quantities, we're doing just a ratio. So if I compare 8 over 12, that's the first ratio. That's the first one I'm going to look at. Yes. Hold on that, Patrick. Now I need to see if another pair of sides are going to give the same proportion or the same ratio. So I'm going to go now, I'm going to go 40 to 54. And then 40 to 54. So I'm going to compare, and watch, this is important. If I put this triangle on top for this ratio, I have to put this side on top again. So this guy is going to go on right here. And then the 15 is going to go on the bottom. All right, so those don't look the same. No. If I simplify them, I have to get my ratios the most simple form, because right now, those aren't the same, so I'm like, these aren't similar at all. These don't even look alike. But if I simplify this fraction, what's simplified of 8 over 12? What's simplified of 10 over 15? Does 2/3 equal 2/3?
No. 2/3 equals a quarter.
Does 2/3 equal 2/3? So I just compared two sides. I took these pairs and I compared them. When they're the same like that, these polygons are similar. So this is yes. The sides are proportional. And angles are congruent. So that's the only thing I have to check. I could check this last one. I could check these last pairs right here. 16 over 20. But guess what? I'm still going to get the same thing. Do what?
Can we track the picture with this stuff?
No. I'm going to have the tick marks. Or I'm going to have that this angle equals that one. And you'll see it. So you can't always trust the picture. Trust the numbers. If there are numbers up there, that's what you use. That's a good question. Alright. So let's look at number 2. What shape is this? A trapezoid. Oh, what kind of trapezoid? Isosceles. An isosceles trapezoid. We just saw it on both activities for triangle. Let's try it on trapezoids. Alright. So, are all my angles congruent?
Yes.
That is congruent with that. This is congruent with this. This is a lot easier to see when they're the same, like this. In triangles, whenever you have it like all womped and flipped and everything, you have to find those angles. But these, the corresponding angles are just the same with the shape across. So check. That's my first check. Now I have to check if the sides are proportional. Alright. So if I do, look, 105 connected to 105. 105 connected to 105. So my ratio for that would be 6 over 4. Now, let me do 105 to 75. 105 to 75. I could have done either one of these two. Because guess what? They're the same. So either way I go, it's going to be the same. So if I do 12 over 8. All right, what's 6 over 4 simplified down?
3 over 2.
What's 12 over 8 simplified down?
3 over 2.
So, are these trapezoids similar?
Yes.
Yes. Good job. So yes, similar. Now on a test, I don't want to keep going through and keep writing similar, similar, similar. Kind of like we didn't want to write congruent, congruent, congruent all the time. There's symbols and there's a way to write these statements about if a triangle is similar, if their sides are congruent, all that. All right, so on the right side of y'all's page, flip over. So these ratios, like we saw in the GeoGebra, these ratios are called something specific. This side compared to that side is called the scale factor. So right here, the ratio of the proportional sides is called the scale factor. Okay? So if we look at the ratio back, what was the scale factor of the triangles? What was the ratio that we found
3 over 2.
for the triangles?
I mean,
2 over 3. So for the triangles, the scale factor was 2 over 3. Going back to what we talked about ratios, what's another way I could write this?
2 semicolon 3.
Good. Okay. What about the trapezoids? What was the scale factor?
3 over 2.
3 over 2. What's another way I could write that?
3 semicolon 2.
Over 2 or 3 dot dot 2. So that's it. That's really the biggest thing about these similar polygons, is noticing these two relationships. Now that we know these relationships, we can use it to solve for missing pieces. But let's talk about how to write these first. So before the symbol for congruent was that equal sign with a squiggly. Now the symbol for similarity is just the squiggly. I don't even know what the adult word is for that. Alright, so look, I started this because it's important. I don't know, that's what I'm saying. So a valid similarity statement must match corresponding sides and angles. So when we write it, we have to be really specific on how we write it. Okay, so watch. So J, K, L is similar to P, M, N. Notice how I picked out those pieces. This is telling me that the corresponding angles are in the row. So you look at what is first in the similarity statement. So J is congruent to P. So these angles right here, angle J is congruent to angle P. All right, going next in line, you have to read this in the row. What is angle K congruent to?
Angle M.
Angle M, the one in the middle, just like how he's in the middle. Good. All right, last one. Angle L is congruent to angle N. Perfect. So notice this triangle was flipped on its side compared to this one. So when you're reading these similarity statements, you have to look at them really carefully. Because if I just saw this picture, I could just run and say, K is congruent to P. And that's not right. We have to make sure the sides are congruent to them. So now, the sides are the proportional ones. Okay? So these sides should be proportional. Just, I want you to write the corresponding. So up here, we're just doing the corresponding. Angles and sides. Okay? All right, so the sides that are proportional, J to K is proportional to who? I have to follow the angle. J to K is proportional to P to M. Perfect. Follow the angles. Okay? J to L is proportional to who? N to P. And I run out of room, but y'all can squeeze it in. And then the last one, K to L, is corresponding to M to N. Good. So fill that. So these are the corresponding sides. This is what you're going to pay attention to see if the ratios are the same. You have to do this one to the corresponding side of that. Just follow the arrow. Alright? Look at this guy, number 2. Do you see the 2 different triangles in that? It's like, here's the bigger one, and then the smaller one is like written inside it. It's like inscribed. You're going to see a lot of these drawn out this way. But these are still following the similarity. Alright, so now we got to talk about the corresponding angles. Who is R? Be careful with this. If I say X and R are congruent, Y and Y are congruent, and Z and X. So they share angle Y. They have the same angle at that. The other two are different. So who is angle R congruent to?
Angle X.
Angle X. Who is angle Z congruent to?
Angle X.
Alright, and who's angle Y congruent to? Itself. Good. Thought I would trip you up. Alright, now, this is a little harder to see. But for them, when they're inscribed like this, the corresponding sides are laying right on top of each other. So watch. Alright. X to Y is proportional or corresponding to R to Y. Y'all see that? Okay. Who is X to Z corresponding to? RS or SR. It doesn't matter which one you get. As long as you're connecting. Good. Alright, last one. Z to Y is corresponding to who?
S to Y.
S to Y. Good. Alright, so just like before, that's just matching. Does that make sense, everybody? Alright, do number 3 with these trapezoids. Try to do it.
Okay.
Use a similarity statement. J, good. Yes. Now do the sides. You see it?
So J to K is like U to R.
Easy?
So J, K. K to L.
Okay, girls.
K to L is
Follow the similarity statement. Just follow it in a row. So J, Okay. Just like that. Okay. Your angles are good. J to K. Okay, so this is where I'm at. You can't just go. Okay, so like let's say A is congruent to okay. Oh wait, J. L. So when you do the sides, match those. So you see how J goes to K, so it goes from 2 to 1 to go to 2 to 1.
Yeah, I know. It's like really. And then you don't need credits. You don't have to say
Are y'all good on the sides? Those might be a little pretty. Alright.
You should have heard what they said about the lead letters.
I don't want to hear.
Get back quiet and tenor. Get back focused on what you're supposed to be doing.
You could have got it from Duke to Dallas.
Alright, y'all are doing awesome on the angles. I think I need to go over the sides one more time. So I showed Emma, I was drawing on Emma's sheet, and I realized I probably should have done this with y'all. What'd you do? Good. Alright, so she was gonna, y'all are doing what I was about to do, but I was just gonna use notation. So y'all did awesome on the angles. What was the first corresponding angles? J and who?
Q.
Q. Who else?
K to R.
Alright, y'all. Look up
L
here.
to S. And then M to put.
I'm glad if you got it, but let me help the people who didn't. Alright, so Taya and Ethan used a symbol system. They said J goes to Q, so they did a little squiggly. Circle. Circle to circle. And then K to R, what symbol? Box to box. S to M and P are squigglies. Oh, sorry. And then what was the last one? Just straight lines, underline. So that's what they use to do the sides. But really, if you want to be more precise, I did little, remember we were on a test? You have those little tick marks?
That's what I did.
And you match to the other tick mark? So you can do it like Taya. That makes sense to you and Ethan. But watch. You could also do this. K goes to R. J, so 2 tick marks. Go to 2 tick marks over here. L, 3 tick marks. Goes to S, 3 tick marks. M, 4 tick marks. Goes to P, 4 tick marks. So when you're making the sides that are corresponding, go to the same shapes or the same tick marks. So if I do J to K, look, I go from 2 tick marks to 1 tick mark. So I gotta go over here and find where is it going from 2 tick marks to 1 tick mark. So that says Q to R, yep. So if you didn't get this on your sheet, just copy it right here. K to R. Oh wait. K to L. 1 tick mark goes to 4 tick marks or 3 tick marks. 1 to 3 is SR. And you just keep going. Does this make a little bit more sense now that I'm doing the tick marks?
Yeah.
The numbers that went away, I should have seen that coming. But it's okay. If you came up with a little system, I'm going to tell you, and Ethan said that, little pictures work if the tick marks are too small. But all you're going to do is, again, 3 tick marks to 4 tick marks, LM, goes to 4 tick marks to 3 tick marks, PS. So this is a picture that's flipped around. I can't just match L to M to R and Q because it's flipped around. I have to go from angle, corresponding angle to corresponding angle to get that corresponding side. Easy enough?
Yep.
All right. Oh yeah, there is actually. What's the last one you did? JM and QP. Yeah. So that's a good one. There are 4. Look, there are 4 angles. So we have 4 corresponding angles statements. There are 4 sides. So we have 4 corresponding sides statements. Ooh, that's a lot of S's. Alright, sound good? So now we can talk about, we can use this proportionality or use these ratios to solve for missing sides. Okay? So if I compare, these are side by side, so I didn't do the tick marks, but let's say this was this, and this was this. And this was this, this was this. So if I compare 1 tick mark to 2 tick marks, okay, over 1 tick mark to 2 tick mark, 15. We saw that if this is similar, which these are, these triangles are similar. If these are similar, all the ratios should equal. So if this is 10 over 15, this should equal whatever this side over this side is. Alright? And we've seen that. How do I solve that?
Cross multiply. You got cross multiply.
But I want to find x. So if I do 2 over 3, that's good. If I simplify this, I know it needs to be 2 over 3. But I want to find what x is. So if you can go backwards like that, that's fine. But how do we solve this?
Cross multiply.
Cross multiply. So I'm going to take the 10 and the x, and the 15 and the 12. 10 times x gives me equal to 20. Divide by 10. And x equals 18. I can check myself because Hatcher just said it. 10 over 15 to give me 2/3. So if I just found x, I can plug this back in and I should get 2/3. Do I get 2/3? Yes. So you can go back and you can check yourself and make sure you solved these right, because you know that these sides need to be proportional. Alright, let's talk about 4 and 5 before I let you run with it. Because this is written a little bit differently. This is a little bit differently, but we're still doing the same idea. We're actually grabbing onto what we did last class with this scale factor number. Alright, so the scale factor is 2 colon 3. How should I write that as a ratio? 2 over 3. So I know all of these ratios should simplify it down to 2 over 3, kind of like the shape above. But if I know 2 over 3, if I do this corresponding side over this corresponding side, what should it equal? Okay, hold on. Yes, yes. It should equal 2 over 3. It should equal that scale factor. Because remember, the scale factor in our GeoGebra activity, our scale factor was just the ratio of all the proportional sides. So this over this should equal the scale factor. So they just figured it out. But if I cross multiply, I'm going to get it. So 2x equals divide by 2, x equals 63, just like they said. Again, I could go back and check it and do 42 over 63 and simplify it. I should get the same thing. Alright, let's try this one. The scale factor is 6 colon 5. So I gotta do 6 over 5 should equal, alright, this is tricky. Notice how it's going from bigger to smaller. You see those numbers? 6 to 5. So if it's bigger to smaller, I gotta go from the bigger shape to the smaller shape. Same thing over here. 2 to 3 is going smaller to bigger. So I go from the smaller side to the bigger side to get that. So James just said it. But I gotta get this x and this 28. Bigger to smaller is x over 28. Cross multiply. And I should get it. 5 over x equals 40. No, that's not it. Yes, it is. Is that right? 168, 28 times 6?
Is it 33.6?
It should. Did I set it off wrong? 6 to 5 x 28. Let's just roll with it.
So it can be done.
Mm-hmm. What'd you get? X equals what?
33.6.
Alright. Sound good?
It's just 33.6.
Oh yeah, I could just do 0.6. How many decimal places do you want to get? Alright, so 6, 7, and 8 is a try it on your own. But look at number 8. This has this big equation. I want to see if you can do it. You're setting it up the same exact way. And you're solving it just like we did last class. Alright, so try them out. Try 6, 7, 8 on the bottom of that sheet.
You have an eye in your eye. No, it's okay. I'm gonna do it.
Yeah, you can do it. But yeah, no, y'all use the similarity statements at the top.
Do we need to go on biggest?
So use the course. So look, A goes to, you had this other one, right? Yep. So now we need to do 8, underline the circle. Over, underline the circle. Equals, circle to square. Over,
This ain't gonna.
Use the similarity statements, y'all, to find out which ones are corresponding. I want to know.
We got different answers.
You look at the similarities and figure out what it is. Yeah. But I went to order like I thought it was together like this one, this one.
I love circle to square.
I don't know. That's why I said leave it like that because I don't know which one's right. But I did
I just want that.
We're working on it. We're trying to figure it out. Really? We can send you back to Alright, Kylie. 75 and 40. What y'all think?
We didn't know. 20 over 20. Or is it 20 over 28? Because we did it.
20 over 20. Because watch. So if you go 80, I'm going to do little strings.
So if I do 75,
Okay?
then I gotta do eggs. What is that?
You would be the same thing anyway. Because say if you put the X on the bottom and this on the top.
So now if I want to do this, circle to square.
Did you get
Yeah, 75 over 20.
Okay, so you go in this order.
Yes, go in order of the similarity statement.
So it's the answer's
Oh.
So both of them.
Yeah, we got it.
Makes sense?
So it'd be S.
What y'all think? Alright, let me go over this one more time, y'all. Alright, y'all, look up here. We have half the class. We're getting it. I have half the class. We need just a little support, so it's okay. What I meant was, by using the similarity statements, I have to label them just like Taya did. So it needs to be organized. It needs to be organized. I can't just go in and start matching. So that's why I was telling you, when we do corresponding sides, I have to do the congruent angle to the congruent angle, to the same congruent angle to congruent angle. So watch. If A goes to D, I can put one underline A to D. Who goes to B? E. So 2 underlines for B, 2 underlines for E. Last one, C. 3 underlines for C. Who does C go to? F, in the similarity statement. So before I even start running off with these numbers, I have to pay attention to this similarity statement before I can go through and start doing my proportions. Because watch, this is the first one I went to. So 1 underline to 2 underlines gives me 25. So 1 underline to 2 underlines gives me 25. On the other triangle, I have to go from 1 underline to 2 underlines. So 1 underline to 2 underlines gives me X. So that's the first comparison. If I do the other side, I gotta go 2 underlines to 3 underlines is 20. Over here, whatever 2 underlines to 3 underlines is 28. So then we could solve that. Just like an equation, just like a proportion with cross multiplication. So we have to use these similarity statements to know what to label and to know which are the corresponding sides. Because this gets confusing after a while. So then let's do the corresponding sides of this one, or corresponding angles. So P goes to W, underline, underline. Q, 2 underlines, goes to X. I know this takes a long time, but we gotta do it so we know which one goes to which one. Okay? Who matches with S? So again, the same way, I go and look for my numbers. P to X, 1 underline to 4 underlines, has to be compared to 1 underline. That was supposed to be 4. No, I mixed up my little one. So 1 underline to 4 underlines needs to go to 1 underline to 4 underlines. So 75 over 40. For those who need it a little bit, is this making more sense?
Yes, ma'am.
Yeah? Alright, again. I find wherever else my number is, 4 underlines to 3 underlines is X. Over 4 underline to 3 underline is 32. From here, y'all are doing great. Y'all are solving perfect. It's the setup that we have to work on. Alright. So, now that I helped y'all out, I want y'all to try to fix this one. Do the same thing. A goes to K. You do that one. D goes to X. M goes to U.
Yes, that's right.
Alright, use those tick marks to set up your equation.
And then I'll turn it to the equation and just like a
Equals what?
Cedric Crosby was
So when you're comparing them, they go underneath. No, you don't have to use the bathroom, but you can go. You can take the pass and go to the bathroom. Of course. Alright, it's a little bit. You good?
I'm gonna finish working on that. Okay, I was making sure you have enough.
3 by 3.
How'd you get through? For me.
X equals 22. Oh, you got it. I forgot.
I got 21, sis. What is this out here?
$32 times 6. I'm sorry. What am I the next one? Did I show you? Are you going straight home? Okay. Well, when you finish it, it's going to tell me if there's anything free. I'm probably watching it. Maybe I should watch it. Actually, that's it. Running with basketball. I'm playing basketball. Oh yeah, they don't play basketball. You have kind of two.
It's just like another standardized test.
Oh.
Like,
I have coach climbing.
alright, makes more sense, y'all?
Yes.
I helped them smart now.
Alright, y'all, perfect. Perfect. And honestly, y'all are really getting the idea. That's awesome. Alright, look up here. Y'all are getting the idea and getting what to use for these. All we have to work on, alright, y'all. All we have to work on is labeling and knowing what to get. So really all we need to do is practice a lot of it. You just need to see different types of questions, different types of ways they set these up. But we're still doing the same exact thing. The same, using these relationships, using these similarity statements. So, y'all saw it on the board and after I asked about it, we're playing Go Fish. So you're with your partner. So look, this is called Go Fish. You are all fishermen. Well, one person out of your team. This is your pond. Here's your pond. So if Alyssa, look, so you know the directions. Alyssa is my fisherman. She's gonna go in. She's a blind fisherman, and she has to go in without looking and grab a problem. She's gonna get a problem. There's a number, and then it's on a different color. You're just gonna do this problem with your partner on an extra sheet of notebook paper. We have paper up here if you need it. You're gonna work it out, and then you're gonna come up to me or me, and then we're gonna check your answers. All right, and I have the answer key. It's really just setting it up just like this, and we're gonna be solving for X. We're gonna be using these same relationships. That's all it is. But we just need a ton of practice on this so y'all can see different ways of solving. Okay? So you just need have two notebook sheets. Y'all are gonna turn this in. Because I wanna see, this is kind of like your exit slip. I wanna see how y'all are doing. Okay?
Hey, Emma, can I have this one?
Alright. So who wants to fish first? I'll send one person to fish, get paper out.
You can have right now. You can get put one of them three over here in there.
I feel like
What are they? Girls hit me with this. I only held this thing. They look fun. So they taste just like peanut butter and jelly. I want those. Different but good.
If you have a white problem, come to me. If you have a yellow problem, you go to Miss Weed. We'll check your answer and then get a new one.
We have number one.
As long as if you do the big one first, when you do the next fraction, you have to do the double first as well. You just got to decide the order. They should match up.
Miss Lee, do we write it on one paper?
Two. I want you to both turn it in.
Oh, okay.
Yeah, that one or that one. Yeah. It doesn't matter which one you put on top first, you just have to match it to the same thing. Yeah, don't do this one. Actually, no, you're right.
That's the whole big part.
Okay, so J. So it's J.
Oh, I just want to know what the scale factor is.
Good job, Ty.
So this over this. I just want to know. So if you have
Tyler. And then first on the box.
This is crossover, okay, so 42 times that, and then start it from. So do 42
That's
times
right.
that, that's 39, and then in parentheses do that. And then you'll have the expression.
Which is good.
So,
Oh, wait.
I did it right. I got $50.
How is this going?
Yep.
You fish in the
I
bucket
have
for
the
a
pond
couple.
if you need the
oh,
pond.
it wants you to turn the perimeter.
So once you got it, come back in there.
You just didn't read the full question. Perimeter is. Yeah, what question is it?
Where's the bucket?
Yep.
Alright, so y'all got it.
Go ahead.
We're working. Where's that? Oh, right there. That's the one I thought it was LD. Squiggle straight. Squiggle straight. 45.
Did she already check it? Alright, grab another one.
I don't know the answer to that.
Right underneath her butt. Me too. Like right underneath so fast.
All those wonders too.
And I feel like my whole body is
Yeah. I don't know how to do why. How to find why.
Okay, set it up the same way. Let's do it the Y side.
I did, but where's the other side?
So Y goes to 45, and then you could use a Roman number. So J, B, C, and M. So 40 over 16. Oh, wait. 16 over 40. Sorry. 16 over
That setup is correct. 17 times that.
Do you want one?
No, I don't like peanut butter, unfortunately. I wish I did. There's so many good things with peanut butter. Good job. Good fish.
I don't like
I think almond butter.
Wow.
But I did set your wallpaper.
To what?
Look on your home screen.
And then do 25 and 6
Where'd you even find that?
I just looked at your camera. Open there. Ready?
Open there.
This is saying this side to this side. You gotta do that on each side. Like do the corresponding sides equal. So you did 12. Let's try to solve it.
You gotta find X and Y. That's what's missing. So we need to set up. Alright, so set up.
squeezed so hard yesterday and I was fighting.
Those push-up things are hard. With Bradley?
Yesterday, I think
No, they were not. The one with the running push-up.
Do another set. What else?
We had to lane them to the push-ups?
Yeah, those are easy.
Some of those groups that do those are
No.
First had your leg like 90 degrees and your hand on the inside. Some people had their knee way back here and it was
Alright, do that.
We're gonna go with the ankles. We got one example.
Miss B, where did Whitey go?
Miss B. Miss Wade.
So y'all do know.
Miss Wade.
What number are you on?
Number 4.
Alright, so, you see how it's a triangle and a triangle? So you gotta say, this side would actually be 20 plus 8. So it would be 28 over 20, because that would be the small triangle. Okay, so write this down, 28 over 20. Okay, and then we did the big triangle first, so do the big triangle first, so 2x plus 3, so put equals 2x plus 3. Okay, and then small triangle. And I want you to cross multiply.
He's like, no, just do what you want. If we do that today,
Okay, y'all get another one?
I just want to know where we are.
Okay, I need these. Equals,
so the angles would be angle Okay, FG is congruent to JK transcendent. GH is congruent to
Actually, Paige, yeah, you're probably right.
This way.
cross multiply and so.
Finish up the one that you're on, get it checked on, be in this way.
Okay, so y'all get everything turned in.
If you just started online, turn it in. If not, turn in your sheets. Get ready to go.
You are getting that.
Baby, come back. I don't want these.
That's right. That's right.
And I can't. Are those peanut butter thingies good? What is it, like a granola bar with peanut butter in it? Cluster of granola.
Make sure Dave's already turning into the triangle.
Alright, the conclusion I have made for today is y'all both like eating. But it's okay, because I'm pretty sure everybody in this room loves eating. Food's great. Alright, here, I'll put up y'all's calculator.
Alright, make sure you turn it around.
your names up. Turn your sheet. Yeah, no, let me get it. Put your calculators up.
Ria, say something.
Love you.
Turn in